Hello, everyone. My name is Stephanie Boozer. I'm with CUGC HQ, and I am so happy to welcome you to today's Connect webinar with HPE. We're going to be talking about Moonshot 750. Lots of information to get to today, and I know you're all really excited to hear about it. But before we dive in, I have just a couple of announcements for you. First of all, just a reminder that our CUGC local groups are still meeting. Even though we can't meet in person, we're meeting online, and you can see the calendar there. We've got several meetings coming up. And also, we're still having our Excel meetings. We're so excited about that. We had to work out a new virtual venue to host those, and we are sad that we're not traveling around the country and abroad to have these meetings in person. But we're doing our best to pull together all of that feeling of community, networking, and everything that's so great about our Excel meetings into the virtual space. So 2 are coming up pretty soon. Next week is the UK groups meeting on the 16th, and then in July, also on the 16th, is the Great Lakes region. So definitely check those out. There is a link in the chat for you to our events calendar. You can get all of the details for all of the CUGC to go local group meetings, as well as the Excels through that calendar. All right, so just a couple of housekeeping details for you today. We are recording today's presentation. You'll get a link to the recording tomorrow. It's going to come in an email. It'll come directly from GoToWebinar, so be on the lookout for that. Also want you to submit your questions anytime. We're going to save them for the end, but we do want you to submit them as you have them, just so you don't forget them and we can line them up in the queue. And finally, towards the end, after we've gone through the Q&A, I have a short survey for you. It's anonymous, it's for CUGC use only, but I'll put a link in the chat for that later on, and we just like to get your feedback. All right, so keeping an eye on all of those questions that you're going to have for us today is Jen Sheeran. Jen is a Tampa CUGC leader. She is one of the mentors in our Women in Tech program. She's also a CTA, and she's going to watch all the questions for you. So Jen, would you like to say hello to everyone?
Greetings from sunny Florida, everyone. Like Stephanie said, I'll be watching the question box, so please post away. Thanks.
Thank you. And now I'm going to hand you over to Cyril and Neil. I think they have some intro slides that they're going to do for themselves, but just really quickly, I'd like to welcome Cyril Hug from HPE to our webinar stage today. And Neil Spellings, of course, is our UK CUGC, one of our leaders over there. He is also part of our Women in Technology program as a mentor, and he is a CTP. So with that, I'm going to hand the screen over to you, Neil, and let you guys continue to introduce yourselves and get us started.
Thank you so much, Stephanie. And thank you for having us. Also, thank you all of you guys out there for joining today. And we're really excited to talk about what we are doing at HPE with Moonshot to increase user experience across a broad range of user groups. In fact, one of HPE's key mission statements is to advance the way people live and work. I argue that end-user compute has never been more important to achieve that mission. But before we get into it, we want to introduce us really quick. And I'm thrilled to be joined by Neil Spellings. Neil, why don't you introduce yourself real quick?
Sure. Thanks, Cyril. Yeah, hopefully many of you online know me already. I'm an independent consultant working out of the UK. I've been working around Citrix technologies for 20 years now, a CTP, and I've recently done a lot of work on the HPE Moonshot platform, especially in financial services. So it's great to be able to share some of that knowledge and experience with you guys today.
Thank you, Neil, and congratulations again on your 2020 CTP appointment. That's really great news.
Thanks, Cyril.
Myself, I'm Cyril Hug. I'm part of the global Moonshot and Edgeline team based out of Houston, Texas, and I'm focused on delivering end-user compute and big data solutions on our Edgeline and Moonshot portfolio. And before I hand over back to Neil, who will talk to you much more about the use cases and why it matters in terms of user experience, I'm going to take you through a quick journey of our Moonshot platform and where we are today. Now, some people of you might already know the Moonshot platform, but most people, when they hear the word Moonshot, they think of these three things. First and foremost, the typical association is with space. That's even more true right now with the recent SpaceX launch we had. Usually very bold men that go into space. The second thing I found is that Moonshot is used as a term for a methodology, a framework to set bold statements, bold goals, and bold missions. And I found a quote here on the internet that describes the mission around sustainable energy resources on our planet. And then last but not least, the HPE Moonshot team actually found out that there's a gin named after our great product, or our product was named after the gin. We're not really sure about that. But if we take a look at the next slide, you can see what I think of when I hear the term Moonshot. I think of this, our 1500 chassis, which has been launched about 6 years ago as part of an HPE Labs project. Let me take you through that system real quick. It all starts with a 4.3U chassis, which is deployable in any 19-inch rack. It holds up to 45 hot pluggable blades, which are specifically tailored to unique workloads. Each blade has a physical network link or two physical network links to the two integrated switches in the middle of the chassis. And these switches are full layer-free switches, which offer all the functionality you typically see in a top-of-rack switch from HPE. Looking at the back, we see our 5 active cooling fans alongside with the uplink modules, which can either be 40 gigs or 16 gigs, depending on customer preference and customer environments. In between these uplink modules, you see what we call the chassis manager. That's the module that controls all the power states of the blades, all the different boot options, as well as all the power redundancy features we've built into that chassis. Now, looking back at this slide I shared before, where I showed the 3 things, I have to say at least 2 of these 3 things I can map or find a relationship to our current chassis. When we started working on this product, we took a bold new approach to server design. We put the application first and built a server around that particular application or workload. And in fact, until this very day, we use low energy system on a chip architecture to drive down energy consumption, heat exposure, as well as data center footprint, all of which leads to a lower carbon emission footprint overall in terms of solution. Now, it didn't take us long to figure out that Moonshot wasn't just built for the data center. We had a slogan once back in the days that we said Moonshot was built for the planet. And we started to deliver on that promise by taking Moonshot out of the data center, using it in a new product that we announced 2 years ago called Edgeline4000. Next slide. Edgeline4000 takes 4 hot pluggable Moonshot blades, 2 on the left, 2 on the right, and is able to drive them outside of a controlled data center environment. And we can do that by using 6 active fan-cooled modules in front of the chassis, which allows us to operate this chassis in higher ambient air temperatures. In addition to that, we also added additional I/O capabilities in the back of the chassis in form of PCI Express lanes. Now we can put any card that's within 75 watts thermal footprint into that chassis, and that can be a data ingest module for IoT use cases, additional network interface cards, or for end user compute. Obviously, we can add GPU accelerators into that slot. Next slide, please. When we take a look at the blades themselves, we currently have 2 different blades in our end user compute lineup. On the left side, you can see our M710x, M710XL, which offers 4 cores at 3 GHz base frequency, which turbo boosts up to 3.7 and one core. We also feature an integrated GPU alongside the 16.4 gigs of ECC memory on the board itself. On the right-hand side, you can see our latest addition to our Moonshot family, the HP ProLiant M750 Server Blade. This platform is aimed at higher-end use cases such as software development, trade workstation, or high-density Citrix Synapse deployments. And it doubles the amount of cores from the M710x, leading to 8 cores running at 3 GHz all-core turbo, boosting up to 5 GHz. We also doubled the amount of memory, so we have 128 gigs available on a single blade right now. As I said before, each blade has a dual port network adapter which physically connects to the switches inside the chassis and also offers up to 5 SSD drives on the blade. One of them being a SATA drive, 4 of them being NVMe, which enables us to drive 16 terabytes of NVMe storage directly on the blade. Starting with M710x, we also introduced ILO to our Moonshot platform. And with the latest M750, we took it a step further and picked up the latest and greatest from our systems management division called ILO 5. And ILO 5 doesn't only help us to enhance the management capabilities, but also makes our platform much more secure, delivering all the goodness of Silicon Root of Trust we have built into our ILO 5 processor. And speaking about management, next slide, please. A lot has changed in terms of systems management over the last couple of years. So it was time to rethink our chassis management strategy. And because we had such a modular design, we were able to redesign the chassis manager in the back of the chassis. And alongside of the M750, we announced what we call HPE Moonshot Chassis Manager 2.0. Chassis Manager 2.0 is rebuilt from the ground up. It's focused around Redfish APIs to make deployment easy and streamlined, and enables direct access to the M750 blades, which makes it even more agile to deploy systems and manage them. We also make great changes to the ILO 5 code. We switched from a derived code to a mainline ILO code, which means all the systems you have from HPE, including Moonshot, now share one single ILO 5 code line, which means when we fix things or introduce system updates, system enhancements, you will immediately pick up on these features on Moonshot as well. On top of that, we made great use of the Redfish and ILO Advanced capabilities by pairing it up with our ILO Amplifier Pack, a well-known product to manage systems in broad scale using firmware management capabilities as well as remote hardware management solutions. We didn't stop there. We used ILO Amplifier Pack to integrate into InfoSight, which is HPE's predictive management solution in terms of hardware monitoring and system alert messaging. So all in all, we are able to deliver new higher-end use cases with the refreshed M750 blade. We completely upgraded our systems management, offer new Redfish APIs to simplify deployment integration, offer direct integration into ILO Amplifier and InfoSight. And this means that Moonshot is completely refreshed and ready to redefine the end user experience again. And I'm excited to hand it over to Neil, who will talk a little bit more about that. Neil, over to you.
Thank you very much, Cyril. So I'm going to cover a couple of things around the Citrix space and also looking at some developer use cases as well. So let's talk about a bit about user experience. So obviously in end user compute, we'll be familiar with the various ways of deploying applications. So you've got your traditional VDI, so splitting a physical hardware into multiple chunks. You've got the sort of Zen app use case, or Citrix Virtual Apps, as it's called now, where you can publish applications and desktops. And on the right-hand side, we've got sort of the physical hosted desktops or Blade PCs. So each of them has obviously different capabilities, user density, cost, and performance. So again, it's a sliding scale, right? Depending on what you want to achieve. So if you want the maximum user density, you're going to start off of the left-hand side, publishing applications and desktops on a sort of Citrix Virtual Apps Zen app type model. If you want the full desktop virtualization or traditional VDI, that's in the middle. And then if you want the sort of performance with the guaranteed level of performance, the physical hosted desktop, again, that's on the right-hand side. So you kind of go for the one-to-one Blade PC model. So on the Moonshot platform, you can do all these 3 delivery models. Some are more optimal than others, but we're going to drill down into a little bit more on that in detail. So three kind of user areas that I've been focusing on more recently is the trader workstations. So I've tended to work in the financial space for many years, and traders were always a difficult bunch of users to move onto a virtualized platform. But they have quite specific requirements, and you've seen the trading floors where everyone's got like 4 or 6 monitors, and trying to kind of hot desk those kind of people, or trying to provide those kind of users working remotely was always really hard. They use highly graphical applications. They've got multiple screens. You've got tickers, Bloomberg, Bloomberg TV, and they're running a whole bunch of applications in parallel. So having a dedicated compute platform to run that on and give them a guaranteed level of performance is always really difficult. And Moonshot is one of the ways that I've managed to achieve this in the past, by giving traders a dedicated cartridge. They get lots of CPU core, lots of RAM. Again, it's in the data center, so again, virtualization technologies means that they can work from anywhere. And again, if they're in the office and need the multiple screens, you have a GPU and you have some graphics RAM in there, which supports multiple monitors as well. Moving on to the middle one, your engineering user. So again, a lot of engineering roles these days tend to be offshored or outsourced. So again, being able to virtualize those kind of workloads is becoming more and more important, and being able to protect your IP. So again, often the traditional VDI wasn't suitable. Again, adding in dedicated GPUs for your engineering applications has almost become a requirement for those sort of CAD applications. But again, those dedicated GPUs are very expensive. So something like Moonshot with the sort of on-die GPUs with the Intel can provide sufficient performance for those engineering workstations. And again, if you need the maximum performance, you can obviously still add the cards into the Edgeline systems as well, where you need the absolute maximum performance. Again, high CPU cores are important for those kind of modeling applications. And again, with the 750s, you've got an 8-core CPU or 16 threads if you include the hyperthreading. Fast loading of models. So again, fast storage is key, especially if you're moving from very expensive engineering workstations into desk, which often have RAID arrays or SSD drives. You want to deliver that same level of performance in the data center. So again, Moonshot helps with that, with the multiple NVMe SSDs, and I'll cover a bit more about that in some later slides. And then finally, on the right hand side, we've got the software development. So you've got advanced developers. They want to be able to compile often large projects very quickly. Again, protecting your IP. So you want to use these virtualization technologies and keep your IP safe in the data center. You don't necessarily always want to give access to people over the internet. Again, low latency for typing. So again, fast performance. You want good performance of web browsing technologies and all the developer tools. So again, I've done a bit of benchmarking around this as well, which I'll cover a bit more. So again, the bare metal use case across all these three use cases works very well. So whether it's a one-to-one Windows 10 or whether it's Windows Server 2016 or 2019 with the sort of XenApp style multi-user sessions. So again, it really depends on if you can share the compute or if you want to dedicate the compute on a one-on-one basis, and again, obviously how much budget you have to do that as well. So talking a bit about storage, most traditional SSDs, I mean, we all seem to have SSDs in our laptops these days. Most of those will work via a HCI connection. So this hangs off the PCI bus, but via a SATA bus. And generally the SATA bus usually has a single PCI Express lane attached to it. So you can see on the diagram, sometimes you do get bottlenecks talking to the SSD actual chips. NVMe helps here because that removes that SATA bottleneck. So your SSD controller sits directly on one or more PCI Express lanes. So you can get data in and out of the CPU and memory much quicker. which is very important when you're dealing with virtualization loads. As you know, can generate high I/O, and low latency storage is key. So anything we can do to reduce that latency is important. Also queue depth, again, so when you're talking virtualization, you're talking lots of parallel I/O. So again, having the ability to have a much deeper I/O queue is, you can see the difference there, 32 on traditional SATA. Even on SATA SSDs, it's still 32 because you've got the SATA bottleneck with the SATA protocol. But NVMe, you've got 64,000 queue depth. And if you look on the right-hand side, this is a kind of a comparison on the number of CPU cycles to do, I think it's 1 million IOPS. So as you can see, the sort of overhead stack of transferring data to and from storage is much reduced with an NVMe stack compared with a traditional HCI stack. So it's generally, you know, any CPU cycles you can save is advantageous. So delving a bit more into the virtual apps and desktops use case. So we've got, again, along the bottom, you've got performance and isolation. Oh, there we go, come back. And then obviously you've got cost along the left-hand side. So bottom left-hand side, we've got traditional apps and desktops. So that's the M710x. Moving up, my slide doesn't want to stay. Settlements analysts, so again, maybe a virtual desktop for those. Wealth managers, going up to the M750s for even more performance. And then for your maximum performance, obviously maximum cost as well, you've got the trader use case on the hosted one-to-ones on the M750. So again, it's a sliding scale. You know, obviously you can adjust, you can mix and match as you need. I think that's all I want to say on that slide. Yeah. So performance testing, everyone should be familiar with login VSI. This slide was so keen to get displayed, I better talk about it. So this is a single cartridge login VSI test. So running the test on one cartridge in a chassis. Server 2016, so the Citrix virtual apps use case, Office 2019. So again, very low baseline. So the lower the baseline is, the better really, because it means that your overall tests complete quicker. So again, this is where your high CPU frequency comes in, because your overall baseline is much quicker. And then obviously your density, which is the VSA max, is 70. So on one of those single blades, you're going to get sort of maximum of 70 users. Obviously this is a vanilla image, so you know, real world you're going to have probably more agents in there. You know, you'll have a security stack, some DLP agents, so each of those agents will knock down this VSI max figure, of course, because they all add overhead to all your compute and storage cycles or filter drivers. So, but this is kind of the comparison for a vanilla image. So, and then obviously these figures are better than the previous one. So this is compared with the 710x, looking at the 750. So increase of 30% more users on the same footprint in terms of your chassis. So this is the test filling an entire chassis with M750s, so 45 cartridges. This is really just to check that the chassis system overall scales linearly, and it does. So again, the baseline is almost the same, and then the VSI max is 2,637, which is roughly what the other one was times 45. So the performance scales pretty linearly in the same chassis, which means that, you know, obviously you can start with a few cartridges and then just add more cartridges to the chassis as your new user needs grow and you need to add capacity. So you know, so great in 4.5U, being able to get 2,600 users. I think it's pretty good figures. So doing some calculations on these. So again, one thing we're seeing from financial customers is that, you know, they want the lowest possible power per user, watts per user figure. So when you're doing very, very large scale deployments, this matters, right? Because you're deploying thousands of these servers, across the world. So if you can reduce these figures even by 0.1 or 0.2 of a watt per user, when you're dealing with tens and hundreds of thousands of users, that is a big figure when it comes to your data center and power utilization. So being able to optimize these figures is important, and Moonshot gives you some of the lowest power per user figures in the industry, which is really fantastic. So the 750, so the 35 watts is a BIOS. So the 35 watts TDP, total dynamic power, is a BIOS setting that allows you to cap the overall power utilization that the cartridge can use. 45 watts is the sort of maximum, so that's kind of opening the tap to full, if you like. So you can see the difference there. So one is 60 users, and then the other drops down to 55 when you're reducing the power. So you're reducing the power by 10 watts, which is a significant amount, but you're only actually getting a drop of 5 users, which is pretty good. And then they've got the M710 figures on there for a comparison. So again, overall power per watts have gone down under the M750. So down from 1.7 down to as low as 1.3, which is great. So slotting this into Citrix Architecture, this is looking at a traditional on-premises infrastructure where you've got some infrastructure. So you might have a normal pizza box running your license servers or virtual machines that run all your infrastructure. Then you've got your VDAs either running a server OS or a desktop OS on the actual Moonshot cartridges themselves. So remember, these are ProLiant servers, so you can put a hypervisor on them if you want and chop them up into traditional VDIs. And again, this makes it's even easier now with the 750, where you've got more cores to play with and double the amount of RAM. It was pretty hard with the 710Xs because you were quite limited in terms of the amount of compute you had. But with the 750, with 16 threads, you could easily chop those up into smaller VMs for your VDI use case. So especially if you wanted to have the same platform across server, hosted desktop, and VDI, you can now do that with the 750 much easier. Again, and then your clients can be your traditional thin clients or multi-monitor thin clients or multi-monitor end user PCs. So the cloud delivery model for that, what happened to my cloud logo? There we go. We've got Citrix Cloud Connector, and then all the brokering and access layer is with Citrix, so they manage that piece. So all you need to do is just slot in your chassis and your cartridges, and then get your VDAs on there, and they will then register through this Cloud Connector, and you effectively provide the same performance, but with somebody else managing all the nuts and bolts for you, which is amazing. So moving on to the developer desktop a little bit, we wanted to find out if this was a good platform for developers in addition to the sort of finance traders that we've seen before. So we did a bit of benchmarking again on the 750 compared to the 710X. So these are the two benchmark scores, and again, significant improvements in just raw compute power in the same physical space of those cartridges and the blades, which is amazing. So what I tested, let's have a look. So HPE 710Xs. So again, this is the Skylake based cartridge, and then we looked at the newer 750. So that's the Coffee Lake one. Looked at a traditional kind of laptop that a developer might have. So I picked a Dell SPX 15, which is an i7 with 6 cores, so 12 threads altogether, with an SSD. So all the solutions were SSD based. We tested, and then compared that with VDI. So I did a VDI on Azure, picking an instance that had a similar number of CPU cores. So I picked a D8S, so that had a premium SSD and 8 cores as well. So all the systems were sort of comparable in terms of compute. Obviously, the 710X has only got half the number of cores, but this is just for a comparison with the previous instance of the cartridge. So that's our test bed, if you like, on the 4 systems. So what did we test? So first I tested an Excel benchmark. Again, this is obviously applicable to anyone really, especially traders who spend a lot of time in Excel. So pretty good performance. Excel just blisters ahead on the 750. So Excel benchmark is a freely available benchmarking tool which stress tests Excel over a number of minutes and then calculates the benchmark based on how fast Excel performs all its calculations and macros. So you can see the 2 Moonshot outperforming the traditional VDI VM and the Dell laptop there. So my developer test bench, I wanted something to stress the system. So I picked Chromium as an open source development project, and also Firefox. They were just generally easiest to get hold of. And they're both quite large. So again, Chromium's about 500,000 source files, and Firefox is more, about 900,000. So with about 14 and 11 gig of source altogether. So I use Visual Studio 2019 for this test, and then the versions are there as well for comparison. So results. So my compilation time for Chrome, so it's in minutes across the bottom. So you can see that I had to wait around for quite a while for my VDI to do this. But again, great performance on the 750, and you can see I was tweaking with power settings as well. Sometimes you can get a little bit of boost setting the BIOS to high performance based on balance. So again, it's power saving versus performance in a lot of the cases. Looking at the raw figures there, so if I can compile Chrome on a 750 in under 3 hours, compared with 7 hours on a VDI, over the space, even if I only do 1 compile a day, that's a working day a week I've saved just by giving the developer a M750. So some great performance benefits there, and even compared to the previous M710X as well, significantly faster. And I think a lot of that comes down just to the multiple cores. So a lot of these big compilations can utilize multiple threads and multiple cores. So obviously with double the number of cores in the 750 compared to the 710X, and the ability to boost up to 5 gigahertz. It really does show a difference when you're doing these sort of high compute jobs like compiling Chromium. Firefox, similar results here, not necessarily unexpected. So again, the VDI was the slowest at nearly 100 minutes with my laptop, just under 80, about 75, and then the 2 Moonshot platforms coming in under that. So again, even here, the 750 almost halved the compilation time from the 710X, and again is significantly less with a traditional laptop or a VDI. So, and I think that's my part done. So I can hand back to Cyril, and again, if you've got any questions, pop them into the chat, and we'll answer them all at the end.
Yeah, thank you so much. That's great content and great tests done. And it really proves that Moonshot is a platform for our customers, which are looking for higher end users, but also great density in the area of XenApp deployments. And we actually have a big install base of these deployments, which Neil has been part of. A couple of these installations actually. You can see we have multiple US global banks which are rolling out thousands of users on these platforms. We just recently had a customer that extended their trader environment by a couple of hundred and not even thousands users because of the COVID-19 crisis. And he had to do it fast because the offices obviously were closed. It was no longer able to access the trading environments he was used to in New York. So having this platform available to him and making it available quickly to scale out has been a huge success. Overall, we have a couple of public references. Typically, large US banks don't like to share their success with our platform because it's a part of a competition advantage for them. We have a couple of public references, one from Baloise and one from Sberbank in Switzerland. So feel free to look at them, and they greatly highlight why we're so proud of our Moonshot platform. Next slide. Now, obviously, the proof is in the pudding, and we have made significant strides in terms of making it simple to get customers into a Moonshot experience and redefine your end user experience, your employees' end user experience, but also maybe partners or as a service provider redefine end user experience for your customers. And what we are able to offer is a remote POC Express, which basically gives you a Moonshot Blade inside a control environment, and you can quickly take a look at the system, install your applications, and make sure it works for you. Obviously, we have great quants here. So overall, the Moonshot system with the M750 sets new benchmarks in every area based on amounts of users per rack unit we can have, based on physical cores we can have in a rack unit, as well as the power footprint per XenApp user and turbo boost frequency as mentioned by Neil. So all these things together really help us to accelerate end user compute to the next level. And we are eager to work with our partners and our customers to make that happen across the board. I also linked a couple of references down here in case you want to browse through them. There are system family guides as well as some additional information on how the platform works. Now we still have quite a bit of time left, so I would like to open the floor for questions and have maybe a couple of discussions going on with Neil, because we have such an experienced technology professional here, which did a lot of these deployments by himself. So why don't we open the floor for questions, Stephanie?
Sure. Jen, I see several in there. I know you're sorting through them, so I'll let you kind of pick and choose which ones you think are best to start with.
Okay. There was a question about redundancy for the chassis manager module. It was earlier on in the presentation. I don't know who can answer that one.
Yeah, I can happily address that. So the chassis manager module is actually the only part in a chassis that's not redundant, and that's correct. However, one thing I would like to point out here is that the chassis manager is a module that's passive. So even if the chassis manager is being plugged out or has some kind of failure, all the blades inside a chassis and the switches will keep running. The fans will go up to 100% to make sure that the system remains cool, does not overheat, because obviously fan control is controlled by the chassis manager. But other than that, all the systems inside a chassis keep running at normal configuration, and a technician can then replace the chassis manager as a hot plug option.
Great, thank you. There was another question about the servers being compatible with Simplicity management.
Right. So SimpliVity, I think, is the question, right?
Yes.
All right. So SimpliVity has a different approach to end user compute and VDI. So SimpliVity is a great platform for virtualizing workloads. We're typically seeing Baremetal deployments. So for most of the deployments we see, we actually do not have a hypervisor. We do not have a shared storage that we usually have in a SimpliVity HCI deployment. So it's kind of a different use case, and therefore the SimpliVity part does not run on Moonshot. It's kind of a different silo and different approach to what we're doing here.
Thank you.
I think my experience as well with when you've got a Baremetal server OS or client OS, running on a fast NVMe, that's more than enough I/O for the number of users that you're talking about on that cartridge. So again, being able to simplify the stack, I think is a good thing. So you've removed the hypervisor. You've got NVMe SSD, a hypervisor, and then the users directly into the operating system. So to get that consistent level of performance, the more layers you can remove, the better. So there's no shared storage components, and there's no hypervisor. So that's two variable elements removed from the stack, which often cause bottlenecks. So again, when you're talking about your gold users like traders and developers and users who have to get a consistently good performance, I think just having that simplified stack can bring huge benefits.
Thank you. There's another question about NVMe on each cartridge or in a model shared, sorry, the screen's going fast, shared with the whole chassis. So is the NVMe on each cartridge, or is it in the model shared with the whole chassis?
Yeah, so the NVMe's are directly placed on the blades. So we do not share the NVMe's across multiple blades. Again, we have 5 M2 ports or connectors on each blade, and can deliver these 5 NVMe drives and SATA drives directly on the blade. So we typically do not share storage. As part of it is what Neil just mentioned. We don't like shared storage in the the high performance way approach, where we want to have dedicated performance per user or per blade. And we typically see that using deployment technologies like PVS make us not use shared storage and kind of neglect the fact that we don't want to have shared storage inside a chassis.
Thank you. And there's lots of questions here. Does HPE have AMD EPYC Moonshot servers?
Yeah, that's a great question. Actually, a question we get a lot. As of now, our lineup is Intel only, but obviously we are exploring what we can do with AMD. AMD has some great CPUs coming up. It's obviously leading the charge in terms of the nanometer footprint, which is very interesting in terms of efficiency of our platform. So we're in constant collaboration with AMD as well as Intel to choose the right chip, which is right for a workload. Again, going back to that whole mantra that we're building a blade specifically for an end user compute environment or a different use case. So we put the application first and then decide which chip from which manufacturer meets our requirements best. And as of now, this is Intel, mainly because of the turbo boost frequencies we can achieve with these parts.
Thank you. So there's a couple of questions about GPU. So is there any license required for the GPU? And then the second part to it is, can this GPU be used for Citrix published app?
Neil, do you want to take it?
Sure. So the GPUs in both 710x and 750 are Intel GPU parts. They're on-die GPUs, which means that there's no additional licensing required. So in the Baremetal use case, you would install your operating system, so Server 2016 or 19, and because there's no hypervisor, you don't need to do any kind of vGPU technology in there. All users just have access to the GPU via the operating system and the GPU's vendors drivers. So there's no additional licensing or license servers you need. And again, every user on that platform can get access to the GPU natively, which is great, because we're seeing Windows 10 and the newer client operating systems need more and more GPU, so Office and browsers, and they're all now GPU consumers these days. So having that GPU ability in every single cartridge, I think gives a really good boost in terms of the overall speed of the sessions and the speed of the sort of typical Office applications and web browsers. Without having to install dedicated GPU cards and deal with all the licensing. Did that answer both parts? What was part 2?
Yes, thank you. So there is a question about how does it compare to HCI for small businesses. It says we bought a small Nutanix 3 years and found us somewhat stuck with update options.
Right. Yeah, so HCI obviously follows a different way of doing things. It's the meaning is having everything converged into one box and then using virtualization technology to make, for instance, storage available across multiple nodes, make CPU performance available across multiple nodes and multiple virtual machines. I kind of alluded it to that in a previous question. We take a different approach, right? We go bare metal. We kind of cross out the hypervisor layer that provides all these functions in simplicity and use the bare metal functions we have on the hardware to deliver these higher end use cases. Usually, one thing I really want to stress here, if you do virtualization, probably a lot of you know it, when you start virtualizing a CPU, you're taking away some of the snappiness of the part, especially around the turbo boost frequency. So as soon as you have multiple virtual machines, the hypervisor slices your CPU time and kind of distributes the frequencies as well, which is not something we want to have with especially the higher end users we deploy on Moonshot. So that's where we want to have the single thread and single core turbo boost performance. So it's a different approach, and typically what we also see a different platform for different use cases.
Thank you. We have a few questions about PVS.
Right.
So they ask is, can you discuss image deployment methodologies? I.e., if you use PVS, would you put the PVS server on chassis? And then another part of that, can the existing Citrix provision server images be used on the new M750 cartridges?
I'll hand over that to Neil because he did so much work on Moonshot.
So the answer is yes, you can deliver images via PVS. It kind of makes sense if you keep your provisioning traffic in the chassis. So the chassis has obviously a built-in switch, high bandwidth, two high bandwidth switches. So if you can keep that provisioning traffic inside the chassis without having to leave the chassis to your distribution switches or core switches, then that kind of makes sense. So you could run your PVS server on a couple of cartridges in the same chassis and then deliver your PVS images to other cartridges in the same chassis. So architecturally that makes total sense. Obviously you don't have to, so if you have an existing PVS infrastructure, you obviously can deliver them over the network through the uplinks to the cartridge in the chassis as well. Whether you can use the same PVS images, that's a good question. I don't know specifically. I think they have the same network chipset. So generally your images are tied usually to the network chipset you're using because of the fact that you have to boot them on the network. Right. And I think because they have the same network chip in 71050 and 710x.
Yeah, so we made some tests, and what you would need to do is a reverse image, right? So if you can reverse image your deployment to an M750 blade, you can leverage the M710x images, and you can do the same if you have virtual images already.
Yeah, I think you probably generally you don't want to reverse image because you need different GPU drivers in there anyway. Because the GPU is different, so you're probably going to want to spin a new gold image purely with your different GPU drivers in there.
It is possible, but it's definitely a cleaner approach if you build it from scratch.
Yeah, I mean, I'm a big fan of automation anyway. So if you can spin all your gold images using some kind of automated toolkit or automated script, I'm a very big fan of that. When PVS isn't your only delivery option, of course. So some of the deployments I did, we used Windows deployment services, and then multicasted the images to the cartridges. So if you don't have a PVS infrastructure, obviously, it's hard to use MCS because there's no hypervisor, and MCS relies on hypervisor cloning and provisioning. So again, Windows deployment services, which is just a rolling Windows server, you can multicast WIM images out at scale. So you can cast an image to an entire chassis or multiple chassis at the same time, which is very efficient. So it's almost like PVS, but you're streaming an image over the network, so, and then that image then gets deployed to multiple cartridges at the same time, and then it's just a traditional kind of sysprep type, image deployment. And again, most of that can be automated. So again, some of the large deployments I worked on, we automated that process so that you could stream an image out every weekend to hundreds of cartridges at the same time. They would just go through an automated build process. So you'd end up with a green field image, an evergreen image every couple of weeks, even if you didn't have PVS.
Right, thank you. Keeping with Citrix, there's a question about doing app layering with the Baremetal deployment. Can it be done?
Oh yeah, I can take this. So app layering is typically something that needs a hypervisor to attach these VDisks to the virtual machine when it boots up. So because we do not, at least not for the Baremetal deployments, we do not support or we do not do virtualization, we cannot add these VDisks when we boot up, right? If you do virtualize on Moonshot, so if you install a Citrix hypervisor or vSphere, then of course this is supported as a deployment model, as it's part of the vSphere stack or the Citrix hypervisor part.
Great, thank you.
Yeah, I think not all app layering technologies need a hypervisor as well. So I think something like Numicent, for example, would probably work because they don't use the hypervisor to do their layering. And obviously, traditional app virtualization technologies like AppV will work just fine.
And just a question just popped up for you, Neil. Why did that project not use PVS? Was it better to redeploy all images versus just updating a single image and stream it?
So there was a desire to have the sort of single image that PVS gives you, but because it was such a large scale and the existing environment didn't have any PVS servers in it, so we had a choice. We either built a global, highly available network of PVS servers, and that was going to be quite complex because obviously PVS, you need SQL servers, you need a way of replicating the images. Another important aspect was that PVS introduces that runtime dependency. So obviously to keep all your servers running, your PVS servers have to be running as well, right? So you need that highly available PVS infrastructure available. Now, we could have built all that, but we decided actually let's remove that runtime dependency. We'll build the servers in an automated way from a single gold image, but utilize Windows deployment services. So that way, once the servers had actually finished building, there was no then dependency on any other infrastructure to keep them running, right? So once your server's built and running, it's booted up, it's got the VDA, it's joined the site, it will just keep going, right? Because it's just using the local VDA, local SSD storage, and you don't need these, huge network of highly available PVS servers to keep it running. And remember, this was going into, maybe sort of 15, 16 data centers around the world, again with, lots and lots of chassis in each one. So it would have been a significant task to design and build that PVS infrastructure from scratch. So we decided to do it a slightly different way.
Thank you.
Hopefully that answers your question.
There was a slide that the trader use case had a slide with 4 screens per session. The question wanted to know if you can have more than 4 screens per session.
Yes, so this really comes down to the resolution of the screens. We had a maximum of, I think 8 full HD screens at some point running on an M710P or M710x, I'm not sure about it. So you can have more than 6 screens. The limitation is really the onboard GPU, where we have to look at the maximum supported resolution. And that varies from M710x to M750. What we found is that typically 4 full HD screens or 2 2K screens is a good combination that works fairly well. When we go towards 4K screens, that's where we usually take the EL4000 and add an additional GPU in the back, like a P1000, which is commonly used on trading floors, to accelerate the graphics to deliver multiple 4K screens.
Thank you. There's a question about can the M710x and the M750 be mixed in the same chassis?
That is a great question. As of now, with the first hardware and firmware release we have with Chassis Manager 2, that is not possible right now. So because we use a different ILO chip, which requires different handling in terms of how we do updates and how we manage the hardware, we currently do not support backwards compatibility with the CM2. However, this is something we're looking at with our development team, and we hope to have that feature later on down the road.
Thank you. Do you have any baselines with versus Cisco HyperFlex?
I personally don't. Maybe Neil, do you have experience with that?
I've not used a Cisco HyperFlex. Can't comment on that.
I think so. Maybe to add one thought. I mean, everyone is cooking with water these days. So most vendors use similar CPUs, if not the same. So if you know your CPU type, there's a high chance that there's someone who did a login VSI test on a CPU and memory configuration already, and that's actually what we're looking at when we design our systems as well. So what other platform manufacturers do. So if you know your CPU, maybe Google that CPU together with a login VSI term, and there's a high chance you will find a login VSI benchmark.
Thank you. Is Server 2019 fully supported on the M750?
Yes.
Okay. And someone wanted to explain a bit more about the turbo boost and why it's relevant.
Neil, do you want to take that?
Yeah, so any Intel CPU or any modern Intel CPU can boost individual cores based on demand. Generally, when you see a hypervisor that has to slice up CPUs across multiple VDI instances, there's generally more load on the CPU. So to keep the overall power envelope within maximum limits, CPUs tend not to turbo boost as much, which obviously does impact the sort of raw speed of calculations. So when you have a sort of single operating system without a hypervisor, it kind of lets the CPU loose, if you like, so that if you get individual compute requirements, you can get more of the benefit from the turbo boost, just from the purely raw CPU speed. So it basically just dynamically adjusts the frequency from the baseline to the maximum. So in the 71050, that can be 5 gigahertz, which is blisteringly fast.
And maybe to add to that, what we found with several customers is, especially if they use legacy applications, which they can't get rid of, they mostly run on single core, single threads. And that's where the turbo boost frequency really comes into play, because it accelerates the application by running a single core as fast as possible. And that's what makes the user experience so much better and so much more snappy compared to a lower base frequency.
Yeah, I think again, having a fast turbo boost frequency can also provide some way of adding. I mean, people talk a lot about GPU performance. I think the benefits of GPUs are more apparent when you have a very, very slow CPU. So the faster the CPU, I think you don't see as big a difference having the big performance GPUs in there, because you've made up for it by having pure gigahertz in your CPU from a performance perspective. So I think having that combination of very fast frequency and a sort of I mean, it's not a huge GPU, right? It's a small GPU on die, but it's enough to accelerate your traditional Office type browser applications.
Okay, let's take one more. I think we're running out of time. There was a question about the new chassis manager. Are there more monitoring functions with OneView, etc.?
Ryan, that's a great question. We get that asked a lot, and the perfectly honest answer is that we took a different route. We did not integrate into OneView because we didn't felt compelled in terms of the capabilities OneView is able to offer. Right? When we look at the whole composable infrastructure story we deliver with OneView, Moonshot is not a perfect fit for that composability in terms of because we don't virtualize, right? We took the route of IO amplifier pack going into InfoSight to deliver the full spectrum of hardware management in our case. However, if you have OneView, the great thing is that we now support Redfish interfaces and APIs. So you can pull in information from IO amplifier pack into OneView for basic hardware management features and hardware monitoring features in OneView. So maybe for the close up, I just want to close real quick. Thank you so much for joining from our side. If you felt compelled by what you heard, please reach out to Neil and myself. You have the email addresses, you have our Twitter handle here. And if you want to test or take a look at Moonshot, we're happy to assist you with doing that. And yeah, thank you so much for having us. Great stuff.
Thanks, guys. That was a lot of questions, and I know we probably didn't get to all of them. I mean, there were just a ton of questions today, which is great. What I'm going to do is get those over to Neil and Cyril, and we'll try to get some more answers out there. Whatever I get back, I can put out on mycugc.org as a forum post. So if I can get answers back for those, I'll post that out there. So you can just come on over to mycugc.org and look for that in the events forum. And if I get them in time, I can add them to the email that goes out tomorrow. Do you guys want to share your slide deck? We had a couple questions about some of the resource links that were in it.
Yes, we can make these available.
Okay. That will be great. So I'll package that up with the recording link as well. So that all of that stuff can come in the email that'll come from GoToWebinar tomorrow. So just be on the lookout for that. And finally, I know some of you may have opted in for a chance to win the Sonos One speaker. We're going to choose that winner at random after the webinar. I have to get the webinar report and get everybody's name in the hat. So we'll definitely put that in the Google randomizer and we'll select the winner. Be sure to follow us on Twitter at mycugc. That's where we'll tweet who won. So follow us there. And then finally, just make sure you check back at mycugc.org pretty regularly. We have lots of forums for you to check out, lots of discussions going on, new blogs. I just posted a new blog this morning, more webinars coming up, and just if you're not part of a local group, it's a great place for you to go find your local group and get involved. So definitely check us out there. And again, I just want to thank you all for coming. Thank you, Neil and Cyril and Jen. Thanks for being with us today. Really appreciate it.
You're welcome, guys.
Thank you.
Thanks.
All right. Oh, sorry, Jen. I hope you all stay safe and happy and healthy, and we will see you at another CUGC webinar or local event soon. Bye, everyone.
Bye.
Yeah.
Bye.